Sorry, we only got 2 more seconds till the next choice is Ali.
Daphne, can you hear me?
Yes, sir.
Hello?
Yes, sir. Clear.
Hello? Hello? Hello?
Yes, sir.
All right. Now my headphones giving me a problem, so I ain't sure if you hear anything. All right. All right. So you wait for 2 minutes more, then we get started. All right, let me start. There are a couple of things I want to do today. Yeah, there are a couple of things I want to do today. The first one is I want to go over review the midterm exam. All right, so we discuss the solutions. All right, the next thing I want to do is give you topics for the final exam. By the way, the timetable confirmed is the 9th of May. What time? Anybody get the time?
No, sir. It's actually the 6th, sir. 9
The
o'clock
6th of May, what time?
in the morning. Yeah.
6th. All right, so there's 1, 2. You got 2 weeks from now. All right. The 6th of May, 9 o'clock. And we talk a little bit about your coursework. I ain't marked none yet. And don't mark though, because lecture notes done. Lecture notes is the hardest thing. So mark not gonna be hard. All right, so for coursework, we not gonna do no assignment, right? We not do no assignment, just one more lab. So one more lab and that's it for coursework, right? So you're gonna be 6 labs, each at 10%, and one midterm at 40%. So they're gonna make up the coursework. And then of course this scale down to 40% overall, and your final exam is 60% overall, right? Good. Now there are some lecture notes that I upload. I'll tell you which ones. Yeah. So the I upload this IPv6 one, this IXP one, source providers architecture, and data center networks. For your final exam, the IPv6 one, the IXP, and the source provider architectures. Those are the 3 additional ones for your study, right? Like I got one more set for do for your exam, which is the 4G ones, and I can submit the by tomorrow night, right? And those the last set of notes for your final exam. All right, so let me go through the topics. I got stop here. I open the final exam paper, but to tell you is one more. Final exam. All right. All right. So the first question 1, is based on IP addressing, right? And understanding how.
Sorry, I want to share your screen.
No, because I'm watching the final exam right now.
Understand? I know. Being
Yeah?
can't put it in memory.
Understanding IPv4 address exhaustion solutions. So that's question 1. Question 2 now is on switching.
So you want to record?
I put in the thing there me, so right now I'm saying to you, is on switching and spanning tree. Question 3 is OSPF. Question 4 is BGP and NAT. Question 5 is service provider architecture and IXP, which is one election what's sent to you. And question 6 is on 4G and 5G. Right? So these are the topics. Share back my screen. So I'm gonna put them back in the chat. Right, so these are the questions. So in terms of lecture notes now for your revise, all right? In terms of lecture notes, what do we see here? Yeah, module 1, module 2, module 1, module 3. Now this one here is module 3. This question is you find it in module 4. Oh yeah, module 4. The DHC module 4, and then this one is on module 3, lecture 4. This is module 3, lecture 3. This one is module 2, lecture 1 and 2. This one is module 3, lecture 1. And not module 4, lecture 1. This one is module 5, lecture 2. And module 5, lecture 3. What was module 5, lecture 1? Can't remember. Oh, MPLS. Yeah. Module 5, lecture 1, 2. Now, finally, the last question. How to say that one? Yeah. There's gonna be what module 6, lecture 1, which I ain't set up yet. All right. So we can put this in Moodle. Good. And we can also change up this here for structure and assessment. Oh, we can edit. Right. No assignment. The midterm is 40. No assignment.
Sorry, you repeat any midterm questions for the finals or?
And 6 labs. Any repeat questions? Yeah. You got 2 or 3 repeat questions. You can see that. At least on 1, 2 things. Yeah, at least 2 or 3. So you work on the midterm now. I'm gonna record this. All right, you ready? Oh, you go.
Recording in progress.
But see, so you gonna walk with me, right? You're gonna help me to answer these questions. So assuming eta5 on switch 2 is blocked, this port here blocked. So this port here blocked, right? Switch port 2. Port 5 on switch 2. After spanning tree processes run, determine the MAC address table on each switch. All right. So this one is simple. So we go on this is switch 3. We do start with switch 1. So you can do switch 1. Good. And then you got the MAC address now, right? And you got the port. So you got the MAC here, and we got the port. All right. So MAC address A, which port you gonna learn it on? MAC address A coming in port 1, ETH1, right? So you can learn this on ETH1. Good. How about MAC address E? MAC address E gonna come in ETH1, and then you can learn it via ETH3 on this port. You can't learn it on ETH4 because this port blocked. So MAC address E is ETH3. Same goes to MAC address C, ETH3. Right? So we see MAC address B. MAC address B packets gonna come in ETH1 and switch 2, and then come in ETH4. So MAC address B gonna be on ETH4. And last but not least, MAC address D gonna come via ETH2 to switch 3 and ETH3 here now. So MAC address C gonna be ETH3. Any questions from anybody? It's straightforward, right?
Yes, sir. Straightforward.
All right, so let me go on switch. Let me go on switch 3. So we can do the MAC and we can do the port A. All right, so MAC address C, he can learn it on ETH1. MAC address A, he can learn it on ETH3. MAC address B, he can learn it on ETH3. MAC address E, he can learn it on. Yeah, this is a typo. You can't get 2 ETH1 port, but it does alright. That's fine. And MAC address D, he can learn it on ETH2. All right, good. Let me go to switch 2. The MAC address and the port. So B is on ETH1. A is on ETH4. So we get MAC address C now on E. Which one you gonna learn it on? What you gonna learn MAC address C on? ETH5 or 4? ETH4. Because
4, sir. 4.
yeah, 4. So everything gonna be 4 because 5 blocked, right? And D gonna be the same thing too. D, even though D directly connected here, it can still come all the way around because ETH5 blocked. So this is switch 1, 2, 3. Let me do switch 4 now. MAC address on the port. All right, just check it quick for that, and then you can call it out to me. I'm gonna send this message. All right, so on switch 4 now, MAC address D, the easiest one is ETH1, and everybody else is gonna be ETH2. All right, so A, B, C, E is ETH2, 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 ETH2. Right, switch 4. Everything else will come in this ETH2 port. So that would be the answer for part A. Now, in terms of explaining how the MAC address on a switch is determined, so I'm gonna repeat back the process for you. So we said we get a switch A, and we get some device A, and then we get next device A, device B, and this port is 1, and this port is 2. Now device A, right? So when device A wants to send a packet to some other device, it does not initially know the MAC address of that device, right? So this means device A does not know the MAC address of device B. So device A will initiate the ARP process. So device A will create the following frame. So the source MAC address is gonna be, like we said, A, assuming it, and the destination MAC gonna be all Fs. Right? And source IP gonna be the IP address, right? So A IP, whoever's the IP address, and destination IP gonna be device B IP, right? Good. Now, when this ARP message is received by the switch, he notices, he does two things. Right? He observes that the source MAC address is A, and it comes in port 1. So he adds an entry to the MAC address table. So you can add entry to the MAC address table, MAC A, coming in port 1. Very good. The next thing, he forwards the frame out all of his ports. Switch forwards the frame out of all of its ports. Very good. When device B receives the frame and he sees the destination IP is device B IP, right? He responds. And when the switch receives the response from device B, puts an entry into the MAC address table. So then you can set a device B coming off of port 2. You understand? That's good? Everybody good to go?
Yes, sir.
Yes, sir.
All right. So that's the question then. All right. Now, assume PC1 is disconnected from switch 1 and reconnected to switch 2. Right? So you disconnect it from switch 1 and reconnect it to switch 2. Explain what happens to the entry for switch 1 in the MAC address table. Now, every entry in the MAC address table got a limited time, 300 seconds by default. Right? So what gonna happen now, right, is that the timer gonna start decreasing, right? And if this PC doesn't reconnect to any other switch, then it can just time out. The 300 seconds gonna expire and the entry gonna get removed from the table because it's a dynamic MAC address entry. When this switch gets connected to port 2, right? You can send a packet to port 2 through port 2. Port 2 now, switch 2 now and see that, look, this device, this MAC address connected here, and I get a new MAC address entry for it. And what will happen now? Switch 1 gonna remove the old entry because switch 2 get a newer entry for this. Right? So that's what gonna happen when the switch get reconnected to another port. Switch 2 now will get a MAC address entry for it, and not switch 1, and switch 1 will just time out the entry. Remove it from the table, and switch 2 and keep it. Right? So that's what gonna happen. So you explain something like that and in simple terms, and then that's the answer then. All right, we got the next switching question here. Give me 1 sec. Good. So let me do this. We gotta redraw this diagram now. Right? So let's save this. Question 1. All right. Good. So this question says, redraw the diagram showing the root, the secondary, the designated ports, and the blocking ports, stating any assumptions made. All right. So the first thing is, right, that the one with the lowest priority, the switch with the lowest priority is your root switch. So this is gonna be your root switch. And the one with second lowest priority now, right, this is gonna be secondary switch. But both ports on the root switch are designated ports. So this is gonna be a designated port, and this is gonna be a designated port. All right. And now the port with the lowest cost, right, to the root switch is your root port. So if we look at this guy, he got 10 gig link to the switch. He got 10 gig link to the switch. This is a 1 gig link. So this is going to become he root port, and this is going to be he root port. The question is, was switch to root port, right? Was switch to root port. Now, they got something here, right? You see this port, they're at 1 gigabits per second, and this port, they're at 10 gigabits per second. Now, this could be a 10 gigabits per second interface on this switch, right? And this is a 1 gigabits per second interface on this switch. However, right, you can't get 1 gig at one side and 10 gig at another side. So these two devices going to negotiate for operate at the lower of the two speeds. So they're going to both operate at 1 gigabits per second. So even though this is a 10 gig port, right, even though this is a 10 gig port with a 10 gig SFP, they're going to operate at the lower of the two speeds, which is 1 gigabits per second. Right, at the lower of the two speeds. Similarly, this is half duplex and this is full duplex. They're gonna operate at half duplex, right? Always the lower of the two. So now this device got a 1 gig interface going out this side, and he got two 10 gig interfaces going out this side. So he can choose this as he root interface. And if this is he root interface, then there's a designated interface. Now the question is, which one of these two now, right, is the gonna be the blocking port? Now this switch got only one hop to the root switch, and this man got two hops. So he gonna be designated, and this port will be blocking. Right, so you follow the steps inside the lecture notes, and it would be simple for figure out. So your network now look like this. Right, like this. Got this port blocking, so this link not operational, and you get it like this. Any questions? You go to this?
Yes, very good.
Well, good. All right. Explain how you arrive at your answer in part A. Well, yeah, you go through and explain the things that you make. You talk in terms of the priorities. The switch with the lowest priority is obviously root switch, and the other one is secondary root switch. And you discuss about the port costs and about the lowest accumulated path to the root switch and so on. Right? So it's not straightforward. This one is a little thinking question. All right. So our PC is connected to switch 3 via access VLAN and VLAN 10. So we take a snapshot of this, switch 3 to switch 4. All right. So our PC is connected to switch 3 via an access port, right? So this is an access port in VLAN 10. Good. PC connected to switch 4 via access port also. So we got the next access port here. Right, so this is PC4. And this is PC3. Good. Now switch 3 port or switch 4 is configured with a native VLAN 10. So this is native VLAN 10. And switch 4 port to switch 3 is access VLAN 10. That's a nice question. Okay. So the one know, right, if the two PCs are able to communicate with each other. Now, for understand and explain this, you gotta figure out what happens on an access port, what happens on a trunk port, right, and what happens with native VLAN. But so we can use VLAN 10, right, as the example. But now on an access port, right? Let's say you're sending in this packet. This is a frame, right? So you got a frame here. So you got your source MAC address. And you got your destination MAC address, right? Source MAC address and destination MAC address. Good. When you go into access port, if this access port is in VLAN 10, then what happens to this? What happens to this, right, on an access port is that you add on a VLAN header. Right, you add on a VLAN header. And in the VLAN header now, you put in 10. So what you do now, you say you tag, right? You add a tag to this frame and you tag it with what? You tag it with VLAN 10. Right? You tag it with VLAN 10. You understand? Good. Now, if this is a trunk port, right? If this is a trunk port don't do anything to the frame, right? A trunk port don't do anything to the frame. What trunk port gonna do, right? It can check what VLAN there on it, right? If it already got a tag of VLAN 10, right? If it's already got a tag of VLAN 10, now this is the packets that come in into it, right? If it already got a tag of VLAN 10, it can allow it to pass through. If it doesn't have a tag of VLAN 10, it's not gonna allow it to pass through. So we talk about what happens, right? About what happens when a frame enters the port, right? We can talk about exit ports just now. So the trunk port, you can just leave it as is, right? Good. Now, your native VLAN, right? Your native VLAN, when something enters it, it do the same thing like the access port. You can do the same thing like the access port. And what we mean by that, you can just put on the VLAN. Wherever you says the native VLAN for this port, you can put on the VLAN, right? You can put on the VLAN. But now we gotta look at the next thing we gotta look at what happens when a frame exits, right? The port. When a frame exits the port. So for access port, right? When you exit the access port, when you leave the access port, you untag the packet, right? You untag the packet. So what you can do, right? If this, right? If this exiting, if this now it ain't the switch, I know you're going to exit this interface, what you can do, you can remove. You can remove this. So the access port, going to remove it. All right, the access port going to remove it. A trunk port, right? A trunk port going to leave it as it is. A trunk port going to leave it as it is. If, right? Only if the port you set at your trunk in VLAN 10. And the native VLAN now, right? The native VLAN gonna also on target, right? You can do the same thing what access port gonna do. So basically, the native VLAN is like setting up a access port on a trunk port, right? So we look back at this thing, you know, this PC now gonna be like this: source MAC, destination MAC. When it enter the access port, right? When it enter the access port, you can put on VLAN 10, right? We can remember when you enter access port, it's targeted to the VLAN. Good. It exit now, it can exit the native VLAN. When it exit the native VLAN, it can take off, right? If the native VLAN is 10, it can take off the header and send it out like this, right? It can take off the header and send it out like this. All right, good. When it enter the access port now we can exit the native VLAN, it can enter the access port. When it enter the access port, it can put on back VLAN 10. And then when it exit this access port, it can take off VLAN 10. So what happens now is that this same source MAC, destination MAC, gonna go from PC3 to PC4. And they're gonna be able to communicate with each other as long as they're in the same subnet. Any questions?
Yeah, sir. I think I misinterpreted. I didn't consider the enter and the exit
No.
on the PC. I just put it like a regular port.
Yeah. So this could be a confusing thing, but you just gotta think about what happens when you enter the port and when you exit the port, right? The opposite things is happening for them. So access ports is always add the tag to it when you're entering it, and when you're leaving it, it is take off the tag, is untag the packets. So that's what happens when you enter the port and when you exit the port. So that's it for this this one question. All right. I gotta spin over Giflan quick. I shouldn't take more than 10 minutes to buy this thing, and then I'm gonna come back, right? And then
Recording
we go to
stopped.
question 3, question 4, 5, 6. We do all of them. Right? So
And that can be the agenda for the night.
No, we watch how the time go now. If we get more time, we can continue.
Well, because I was telling you earlier that Thursday is a holiday, so in
Thursday is
terms of how
holiday.
yeah, so in
Thursday is
terms of how
holiday.
we plan out some kind of
Uh,
holiday, sir.
Next week Thursday, sir. Next week Thursday.
Yeah.
No, if next week Thursday is holiday, we gotta get the next class. I want to reach this Friday, so how we there for Friday?
Yeah, you're supposed to go to Friday, sir.
Good. So we can reach up. Yeah, let me reach up Friday and do some more work. And if next week Thursday is holiday, we gotta get next class, so, right? So we could do Tuesday and Wednesday. So what I want the questions that come in for your final exam, I want to lecture out on Thursday. This Thursday here. So next week, if we do anything else, it don't come for exam. So you don't gotta worry with that. I want everything to take I get for your exam. The latest is this Friday, this Thursday here. Right?
All right, sir.
So yeah, so next week we just talk a little bit about some other stuff, do some final revision, and we good then. So this is basically revision like we do in tonight tickets.
All right, sir.
Yeah. Good. All right, good. So I'll be back in office. All right. We continue. All right. So let me go with this question now. You're required to design a network for an organization with the following requirements. All right. So this is the all right, recommend minimum IP subnet calculations for this. All right. So first we gotta look back at the table. If you remember the formula for number of available hosts is 2 to the h power minus 2, right? But where h is the number of host bits, right? Number of host bits. All right. So if we got a /30 subnet mask, right? The number of host bits is equal to 32 minus 30, which is 2, right? So the number of available hosts is going to be 2 to the second power minus 2, which is 4 minus 2, which is 2. If we got /29 subnet mask, the number of host bits, right, will be 32 minus 29, which is 3. So the number of available hosts is 2 to the third power minus 2, which is 8 minus 2, which is 6, and so on. And we could continue like this, right? Good. So we get for /28 is 2 to the fourth power 16, so it's 14 hosts. /27 is 30 hosts. /26, 62 hosts. /25 is 126 hosts. /24, 254 hosts. And /23 is 510 hosts. So that should cover all the numbers that we got here, right? All right. So for this /40, we can't use the /27 because there's only 30 hosts. We gotta use the /26. So for this one, we gotta use a /26. Good. For this 312, we can't use the /24. We gotta use the /23. For this 234, we could use the /24. And for this 20, we could use the /27. /27, right? Good. Now we gotta take the networks from this 172.16.00. So let me start with the largest one. We can use 172.16.0.0/23. Right? So there's this one here. So /23 now, don't cover, right? Don't cover from 172.16 0.1 all the way to 172.16 up to 172.16, how much way?
That 1.254.
1.255, right? Up to this number you can go up to. Good. So that means now for the /24 subnet, we can do 172.16, right? 2.0/24. So for this one here, we can take 172.16.16 0/23. And for this one here, we can use 172.16 2.0/24. Good. Then we can do the /26 one. So we can do 172.16 3.0/26. That's what we can take for this. And this /26 can go up to, right? So this 172.16 3.0/26. This is from 172.16 3.1 to 172.16 3.63. So that means now
65, sir.
65. You're right. 172.16 3.0/26 is from 172.16 3.1 to 172.16 3. No man, it's not 63. Yeah, 63. All right. /26 is 2 to the 6 power 64. So the next one will start at 64. So that means for this man here, we could use 172.16 3.64/27.
Right.
Yeah.
Yeah.
Right? So this is the networks and this is the number of hosts. And we're taking them from the 172.16.00 network. Everybody good?
So that last one got up to 94, sir. 116.
You're
I see
gonna
that
go
90.
2 to the 5th power or 2 up to 96. The next network gonna start at 96, so you're going up to 95.
Right, 95
So
would
the
have been
broadcast
broadcast.
address. Yeah, broadcast.
Yeah. Good.
All right. All right, we got next one here now. What if you got any questions, let me know. Anybody? No. What subnet does 172.16.94.2/22 belong to? So for do this, we can write out 172.16.94.2 and /22 is 255.255.252.0. I think. /23 is 254 and /24 is 255. Good. So we can write it out like this: 172.16 the 94. We can write out as decimal now. What's 94 in a binary? I mean, what's 94 in binary?
Sorry, 0001 and then 4 zeros.
0, 0, 1, and then 4 zeros?
Yeah.
Nah, something around there, man. It's 94.
Oh, sorry. It's 0, 1, 0, 4 ones, and then 0. Yeah. Sorry.
4 ones? 1, 2, 3, 4, and then 0. Good. And then the 2 is 1, 2, 3, 4, 5, 6, 7, 8. Good. And the 255, we can just write out the like though. And the 252 now gonna be 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Good. So basically, everything up to here can change. Right? Everything up to here gotta stay the same. So everything up to here gotta stay the same. Good. And then what we gonna do, we can set everything else to 0. So the network is 172.16. This is 128.64 toward the 2. What's this first number? 101. Yeah?
92.
92, good. That's 0/22. So that's the network, right? This is the subnet. Good. The default gateway, the force address is 172.16.92.1. And the broadcast address now, right? To find the broadcast address, you take this here, change everything to 1. 1, 1, and last is 255. So this is 172.16. This here gonna be 95.255. Good. So that's the broadcast address. So this is the gateway. This is the broadcast address. The force address is also the default gateway. So this is the force address. And the last address, 254. This is the last address. Good. Any question? All right, good. No bad. Convert /12 subnet to that decimal notation is not hard. Oh, well, I'm already card, but
Recording in progress.
all right, so we can do 255 first. That's 8, and then we gotta get 1, 2, 3, 4. Right? 1, 2, 3, 4, and everything else is 0. Good. So it's 255 dot. Right? So the /12 basically mean 12 1 bits, right? Good. So the 1 is what? 128, 92, 64. 240, that's 0.0. But the /12 is 255.240.0.0. Straightforward. And the last one is convert this to CIDR notation. So the 255 is 8 ones, 192 is I think 1 and low, 1, 2, 3. So you get 8 and 8, 16 and 2, 18. So it's a /18. Right? /18. /18. So 255.255.192 is a /18. All right. Good. Any questions, anybody? All right. All right. So there we go. Let me look at this one. You know, which route from R1's routing table does R1 use to reach 10.10.30.10/32? So R1 here, you know, this is your routing table. This command show IP RO is show IP route, right? So you get show IP route there. And they got 4 routes, right? One second. But you got 4 routes. 10.10.10.0/30. There's one of them. 10.10.13.0/25. 10.10.10.16/30. 10.10.13.144/28. And you get 0.0.0.0/0. Now, none of these ones at the top here, so don't match 10.10.30, right? None of them don't match 10.10.30. So you gotta use this last route, 0.0.0.0/0, which you call the default route, right? Which you call the default route. So this subnet only matched by this last one, which is the default route. So the route that R1 gonna use is the default route, which is the last one. Good. Write the command used to configure the static default route from MLS1 to R1. So the command for the, right? The command for the, so let me save this. Good. The command for the gonna be IP route. You put the destination 0.0.0, the subnet mask 0.0.0 as well. And then he default gateway is 10.10.10. So this is network here, 10.10.10.0/30. He IPs .1, he IPs .2. And you put it as .2. And this is the route used to configure the default static route from MLS1 to R1. That's good? Any question? All right. It's not bad. It's just simple stuff. Good. In figure 4, R1 learns network 10.0.0/24 via OSPF from R3. And R2 also learns network 10.0.0/24 from R2 via static route. What change to the static route on R1 to R2 must be made so the OSPF route is preferred. Now, when there are multiple routes to a given destination, which in turn are learned by different routing protocols, the administrative distance, right, is used. Right, the administrative distance is used to determine the best route. Right, good. So OSPF, the administrative distance is how much? Check back your notes and tell me. What's the administrative distance for OSPF? And for static routes, what's the administrative distance?
Sir, static route is 1, and for OSPF is gotta be greater than 110, I think.
So the static route is 1, good. So the lower administrative distance is selected. So in this case, static route is selected over OSPF. So the command that you gotta use now so that the OSPF route preferred gonna be IP route, right? 10.0.0, and you put the subnet mask there. Good. And then you put the gateway 10.16.4.2, and now you're gonna set the administrative distance. You gotta set it to any value higher than 110. Now, when you put this route, right? When you put this route 10.0.0.0, 255.255.255.0, 10.64.2, the administrative distance 120 now higher than the one for OSPF. So you can choose the OSPF route via R3. That's solid, right? Good. So you explain the concept of administrative distance and so on, and you get this one here, right? All right, let me look at this BGP question. So let me put the network in it. Zoom in a little bit.
Sir, this wasn't allowed.
Oh, this question, eh?
This
Yeah.
network gave you, yeah. Okay.
Yeah. Let's bring a question based on it. All right. So write the network statements to configure OSPF on R1, R2, R3, and R4. Use a wildcard mask so that only the specific subnet for the interface is included. Right? So there we go. If we go on router 1, so it's router 1, 2, 3, 4. Good. So on router 1 now, you know router OSPF 1. They say anything about the process ID? No. So we can send network 10.16.4.0. Right? And then you're gonna do the subnet, the wildcard mask. Area 0. That's it. Well, no, actually area 1. So this is on router 1. So the trick in this, well, not really the trick. The thing to watch for in here is that you only gonna match the interface, right? You only matching this interface. And for do that now, you gotta use the wildcard mask for a /30 subnet. On router 2, we can say router OSPF 1, network 10.16.4.0, area 1, and then you're gonna do network 10.16.4. Let me see, this is how much? It's 4.8, 0.0.3, area 0. Router 3, router 3, you do router OSPF 1, you network 10.16.4.8, 0.0.0.3, area 0. And you do network 10.16.4.12, 0.0.3, area 2. And then on router 4, router OSPF 1, network 10.16.4.12, 0.0.0.3, area 2. And that's the configuration for OSPF on each of these routers. Very straightforward.
Sir, why don't we include the 192 network and 172 network on router 4 and router 1? Is that okay?
If you include the oh yeah, you're right. That's a good thing there.
Okay.
Yeah, you're right. You forget though. So R1 you gotta put in is 192.168.1.0.0.255 area 1. And on router 4, you gotta do network 172.16.12.0.0.0.255 area 2. All right. A design change was made and R1 should not participate in the OSPF process. However, its network should still be advertised. What command must be configured on R2? So those were the passive interfaces come into place, right? So on R2, you're gonna set passive interface, and then you gotta put in whichever interface this is. But the questioning got no interface on it. So let me check back the notes. So that's why I make sure it's passive interface, and then I know.
Sir, either just put in the route and redistribute. In router OSPF 1, I redistribute static subnets.
Yeah, there's one option too. Yeah, so the right command is passive interface, and then you put in the interface that you had to put in. So you could have put passive interface, and you could put in any interface number that you want, and just say that you use it. Those the interface that going towards R1. So when you use this command, and though you said there's an X option, you could do the static route and then just redistribute it into OSPF, right? Those so you could do so this is one option, right? An X option is for you do the no command, right? No network 10.16.4.0.0.0.3 area 1, and then you say redistribute static subnets. All right. So that's the second option that you got. All right, so assuming a static route is configured between R3 and R4, right? How can the networks known by R4 be advertising to the OSPF process on R3? Well, they gotta redistribute, right? You gotta redistribute the routes. So that's the answer for the part. All right. This was a nice question.
View says so, sir.
Yeah. This is a nice question. Right.
Sorry, I could go slow with this question because I didn't go through this question.
No worries,
So
no
I
worries.
see not I didn't go through not on the other reason.
All right. Consider two users with IP addresses. So we got two users here. We got one user here and one user here. And this user now will get IP address 192.168.1.2/24. And then we got next user with IP 192.168.1.3/24. All right, so let me say each of them now connected to some device. Well, which is some router. Good. And the router now doing that or something, go out to the internet. So this here now is internet. Right? And this they're going out to some website here, which is www.com. And here IP is 54.236.192.188. And the website listening on port 443 for HTTPS connections. Good. Now, each one of these devices using a source port, right? Or to 4001. And he using source port or to 4002. Now, this source port is something, if you go on my computer, do netstat -rn. When I going out to some website on the internet, you'll see netstat. Yeah, you see, it randomly choosing source ports to me, right? Depending on which website I go into, right? And see the destination port HTTPS is 443. So, well, for this particular connection that go into www.com, which is 54.236.192.188, the source port is 34.001 and 34.002 on this one. Now, this router doing that, but they're doing that to overload, and the pool, right, that allocated is from 70.001 up to 70.002. So this is the two IP addresses that allocated for it, right? They're doing that to overload. So we got a packet now, right? From this man here, the flow is like this: 192.168.1.2 with the port toward 4001, and they'll go into www.com, and he port is 443. So this is one flow, right? The TCP flow. And then we got 192.168.1.3 with toward 4002. And that's going to that 188.443. That is an XTCP flow. That's called TCP flow. Good. Now, when this packet goes to your router, remember, right? Remember, this 192.168.1.2, you can't propagate you can't advertise or send any packets out with a source IP of 192.168.1.2 on the internet, because this is a private IP address. And private IP addresses can't be routed on the internet. So you gotta do network address translation to a public IP. And the public IPs that are available for this network address translation is 70.0.0.1 and 70.0.0.2. Right? So what gonna happen to the packet now? It's gonna get natted, right? It's gonna get natted. So it's gonna get natted to this. Now it could get natted to either 70.0.0.1 or 70.0.0.2. So one of many things could happen. The new flow gonna be this. Right? That go to 54.236.192.188.443. There's one thing that could happen, and then you get to the 4002 for the second flow that go into the same website. So there's one option that we could get, right? Good. So there's option one. So what happened in here is that this man gets in map to he, and he gets in map to he. Now we get something else that could happen. We could get 70.0.0.1 to 4001, going to 54.236.192.188.443. We could get this happening. And then the second flow could go to this is what could happen to it, right? Now again, next thing that could happen, a next option, we could get the first one going to 70.0.0.1. Or we could get the first one going here and the second one going here. In each case, this combination unique, right? So each one of these options could happen here. So you could get it map to this, 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 and map to this. Right? But you can't keep the original IP address. That address get translated. And they get translated to the addresses in the NAT pool. Understand?
Sure, so there's the explanation.
So that's what happens to the packets, right? So you're gonna explain then, no? You got put in some words then, right? That 192.168.1.2 can be routed on the internet because it's a private IP. So you get NATed to one of the addresses that's on R1, right? So the source IP address 192.168.1.2 you're gonna change to 70.0.0.1 or 70.0.0.2.
Oh yeah, that's it.
So that's what has happened to the packet. The packet get NATed, and then you explain what's NATing and so on. Right. So now, what's the maximum number of TCP connections that can be accommodated with the NAT pool? So this went inside your election once, I think.
You know, we want to be 65,000 for one of the address, right?
Right. Yeah. So NAT overload can use 65,000. So you can use the 65,000 port numbers, the exact number, anything. So if you got two pools, right, 70.0.0, two addresses in the pools, sorry, 70.0.0.1 and 70.0.0.2, then the maximum number of TCP connections, right, is two addresses times 65,000, which is 130,000.
Yeah, sure.
Yeah, TCP connections. Now, each user, you're assuming 1,000 user ports allocated for a user. So the total number of private IPs, all right, going to be 130,000 divided by 1,000, which is 13 private IPs to two public IPs, 70.0.0.1, 70.0.0.2. That's very, very bad. But in reality, it's not so much, right? It depends on how much browsers you are open, because some people got like 5 to 60 browsers open. And then you end up getting enough TCP ports, and each one of them gotta get NAT. In my case, it's not a lot I got here. So those the answer for this one. Everybody go to this.
Recording stopped.
Yeah, sorry. So in reality, how much of them is allocated per IP?
Eh?
How much does
How much?
actually allocate?
How much was, sorry?
Ports them is allocated. How much for part C there? What's your reality? For a user then.
So if you allocate, if you say 1,000 ports for user, the maximum number of private IPs you could get is 13 private IPs. Because the 65,000 ports in all is 130,000 ports in all we got. Oh, this number wrong. It's not, this is 13,000 right there. So it's actually 130.
130, yeah.
Yeah. But it's still a little bit. 130 private IPs is a little bit. It's actually 130 private IPs. Yeah. So that's the answer, 130 private IPs. If you want to
Easy
add more
question.
IPs and don't get issues, you gotta add more addresses to the pool. All right. Let me take a little 5 minutes break and then we can start talking about 4G. All right, well, we finish off. So we talk a little bit about 4G, just an introduction to it, right? I just want to show you what it look like at a high level from a networking perspective, because they got the RF side for it as well. And typically what you just got to do. Let's see this message.
How would you work in time, man?
Whole day. Whenever the calls there. Like I got this thing when I don't teach you so when they set up for. Let's see when these men want it. Yeah, so you see the same thing I teach you all about IXP. We got here with GT&T tonight at 10 o'clock.
So you can't do these things at home.
Yeah, I can go home and do it.
Oh.
Yeah, so I didn't walk here right now. All right, so let me talk. So I give you a high level overview of what it look like, and then we're gonna, from a networking perspective, so you can understand what exactly does happen, right? So
Yeah, sure, sir.
actually, oh yeah, good. See the screen now? Yeah. All right. So mobile communication is the primary form of communication now, right? And 2005 was the year for it. So I went at GT&T on attachment when the CEO at the time, who was Yo, said that their mobile business did outperform in the landline and the fixed access business, right? The fixed fiber customer businesses. So this was around 2009, 2011, 12 time, I think. 2013 went on attachment, they just left. And a lot of the innovations in telecommunications now is on the mobile side of it, right? Especially on the air interface, right? The air interface is from the device to the tower, right? There's a majority of the innovations that's happening because you want more speed, right? And I don't know if you all see this, but China do 10G broadband, right? So these men just bad by. So this is 10 gigabits per second download speed to your house, right? And they do it over PAN networks. It's 50G PAN. 50G PAN is, look at this here. So you could download a 10 gig, so a 4K movie, which is around 20 gigabyte in size, you could download it in 20 seconds, right? 20 seconds. Does mad speed. And how they do this here? So telecommunication engineers, right, had to come up with the modulation schemes and methods so that it's the same air we're using, right? The air from now ain't changed much from the air that these people had in the 1980s when they do 1G, right? So 1G design started in fourth generation, started in 1970, and implementation started in 1984, right? 2G becomes popular in 1991. Guyana get 2G till in 2003, 2004 time. 3G 2002 the implementation start, and 4G start in 2012. Now NDMA, who I work for, was the first company in the Caribbean, right? The first company in the Caribbean to set up a 4G network, right? China did come. It wasn't true 4G, it was 3.75G. I'll talk a little bit about us now. But the first company in the entire Caribbean to get 4G at the time. See if I find the article. 4G e-government network. Guyana, Caribbean, first. See, this article got it. Imagine big government network again. I kind of click on running. Yeah, it's see, there's no more. Was way back when. Yeah, looking at the environment, I see was the first in the Caribbean. But yeah, but 2012 is actually around the same time the technology released. So just to put in perspective, 2G released in 1991, and in Guyana, right, we get it around 2002, 2003 time, right? That was not even then, maybe a little bit after, right? 2005 time. In the pace of innovation, it's slow because GT&T had a monopoly, right? But then 4G, actually when it developed is when we actually get it, right? So that was good. So we already, of course, we already at 5G. There's a little old, we already at 5G right now. So eNetworks is the first company to roll out 5G in Guyana. Digicel got some aspects of 5G. And 5G is 95 gigahertz you get when you connect to Wi-Fi, right? 5G is the 5th generation of mobile communications, right? So it was analog. 2G is when it started with digital. Now it's entirely based on IP, right? So the things that you learn in networking in this course, the same concepts is used inside of it. And the speeds, of course, get higher. And if you notice, the modulation technologies, right, the multiple access technologies keep increasing, keep becoming better. That's the key thing behind the evolution. Good. So first you had amps, right? Then you get 2G, second generation, 3G, 4G. And LTE, which is the one we focus in on this lecture, it long-term evolution, right? LTE. And the organization that is doing the development for them is 3GPP, third generation partnership project, right? GSM is Global System for Mobile Communications. Good. So 4G networks no longer support circuit switching, rather they entirely based on packet switching, right? So I explain to you what circuit switching and what's packet switching quickly, so you get the concept. So let me look at so we got two networks here, and we got some cables between them. And we got one user there, we got one user there. All right. Let me take the same network now. Good. So let me say if we got a user here, want to communicate with a user here. So the first one now is circuit switching. And then this one here now is packet switching. Good. So in the circuit switching concept, right, you're gonna dedicate a circuit to this user. From A to B, you're gonna dedicate this line, and this line for go to the user. Right? So every transmission from A to B gonna move along this here, right? So you get a circuit set up for them. With packet switching now, right? With packet switching, the transmission, or the packets that A wants sent to B, you could break it up into different parts, right? You could break it up into different parts. So this is the whole message, and I split it up into part 1, and I split it up into part 2. Good. And part 1 of the message, right? Part 1 of the message, you could send over the top. But part 2 of the message now, you could send it like this, over this part. You could get a third part, right? You could get a third part to the message, and you could send it over here. The thing is, with circuit switching, right? With circuit switching, you reserve an entire communication channel for one person, right? For one communication. You reserve an entire channel for one communication channel for one communication stream. So I always like to use the example of them speedboats, right? So think of circuit switching like this. You got 10 boats that line up, right? And one boat allocated for each student in this class. So if Daniel want to go across from Hoop to Georgetown, he got he boat that's set for he, and he gonna move across. Now, if Daniel in traveling across Hoop, because of circuit switching, the line just there, right? The boat just there, and it didn't do nothing. With packet switching now, we could share the boat, right? We could share the boat. You could break it up into packets, and you could share the communication mean. So if Daniel is using his boat, somebody else could use the boat as well. So the circuit in reserve fee, the boat in reserve fee. The boat is a shared medium, and different persons could use it. The message could break up and move along different paths. So that's the difference between circuit switching and packet switching. You don't even talk about it anymore, right? It's an old thing. Everybody by default assume you use packet switching or what. I just want to get an appreciation for the concepts. So 4G network up to 3G networks was the last that they used circuit switching. Now everything is packet switching. Everything is IP. Now 4G networks, you had two, right? You had WiMAX and you had LTE, right? So eNetworks was the first company, right, to introduce WiMAX to Guyana. So they try a thing. WiMAX was, a thing back then, 4G. They want to get faster speed for customers, but the circuit was the surface was horrible. No fault to them, right? It's just that the technology and make it. Right? The technology and make it. So they introduced WiMAX 4G and the team up look cool with Huawei of China. Huawei always there behind everything. And it didn't make it. And I think GT&T had a WiMAX too. Yeah, so GTT they using WiMAX, right? And it was horrible, right? It was horrible. So 4G LTE now, right, is the one that majority of companies used to use, right? So think of it as 4 generation of mobile systems gotta give you a certain speed, and then you got 2 flavors of it. You had WiMAX and you had the LTE. So 4G LTE long-term evolution become the better one. Now the thing is, right? People is release. Everybody wants to say their phone supports the latest technology, and every provider wants to say that we got the latest network. And there's kind of the standard don't be fully mature. And there's already started make equipment and market it and advertise it as being 4G. So that's what happened with 4G. People said that they had 4G, but wasn't really 4G. It was more like 3.75G. So then they had they released 4G, but look at what happened. You're only getting 100 megabits per second download and 50 megabits per second upload, right? But that was 3.75G, right? Then 4G get released, and the term for this is LTE Advanced, right? So you had LTE, which was the 3.75G. They marketed as 4G, but it wasn't actually 4G. It's 3.75G. And then True 4G release, and you call this LTE Advanced. And they got better parameters, right? Better specifications. So if you look at the download and upload, you get 1 gigabits per second with LTE Advanced, right? This download and upload, you get 500 megabits per second. And the latency now, you get 50 milliseconds with LTE Advanced. You get 100 milliseconds with LTE. So overall now, right? And the important thing is mobility. The faster your vehicle moving, the slower the speeds that you're gonna get, right? Because you gotta get handover between towers and so on. We talk about the concepts a little later. So LTE, you get up to 350 kilometers per hour you could move, and you'll get certain amount of speeds. But they go up to 500 km per hour. I'm really sure who can move in this fast, but with LTE Advanced, you basically could move faster. So I can stop there. We can continue with the rest of stuff on Thursday, but we're gonna look at 4G first. We look at 4G next week. We do some 5G, and then we got 2 more classes for this semester. Well, next week is short, right? Yeah, the exam is Tuesday. It's very short. So here, all right. Because your exam is Tuesday, you gotta study. You want the next lab, or let me scale the other 5 labs?
Really had 5 labs.
What do you think?
Sorry, you could send the lab, but you could for our practice, but you could scale the 5 that we did already.
All right.
Part of the
All right,
course.
good. Right? So I can do that. I can still send the lab, right? Because I want it for practice and for do it. We can build some bigger
Right,
networks. So I want to make it a little more complicated. And I will scale the other 5 labs. Right? So it'll be 12% each.
So we're not gonna grade the one, right, sir?
No, I'm not grade the one. No.
Okay, so you can just get ready.
All right, so I can finish with the thing name. I can finish this lecture notes here. So tomorrow, so Thursday, Friday, Saturday, Sunday, I can be marking all the time. So I should be able to finish mark up your stuff, because I want to send you with your midterm grades before your final exam. So I gotta do that. Those are things that I gotta do. See, when you're preparing lecture notes for the course, is when you're preparing lecture notes, is like you doing the course yourself, right? Because even though you know the thing, you still gotta put it together, and you gotta put it together from different source and everything, and it's take enough time, right? It's take at least 6 hours, 5 to 6 hours to prepare one set of lecture notes for one class. Sometimes 4 hours, right? If I work real fast.
Go back next year.
No, every year is supposed to review election notes though. It's supposed to keep but like what I said, like how I got election notes for second year, fourth year. They ask me for teach third year, telecoms. Next year, next semester, next year I'm only doing one semester, but I'm teaching second semester. So I might go back and do the ELE class. But the thing is the second semester, I like this course, so this is me course. But I can't make it next year. I got something I gotta do. So only first semester I'll teach. But with the first semester now, the antenna course is hard to teach without the maths, right? Next semester, if you're teaching it with the maths, it's hard to explain some of the concepts them, right? It didn't really think. But now you get to prepare. Now the election notes done, you get to prepare more coursework, better coursework, assignments, homeworks, and like the worksheets and everything, and you have to focus more on the other stuff. Them election notes is like the main man, and then you're getting it from there. So it's a learning process.
Are you expecting maths from field theory?
Yeah, if what?
You expecting the maths antennas from field theory?
If I expecting the
That
maths.
was so that was the issue when you teach the antennas, right? We didn't cover field
No,
theory. and
it
sonic
wasn't only that. It's the actually while we feel ease on the maths a little bit. And try and describe things more qualitatively, but it's hard to do though, right? Very hard. It's engineering at the end of
maths
the
is
day.
not much inside field theory, and because it's being taught separate, they try to
Yeah,
ease
that was the
out
next
the
thing too. You
antenna
had to know,
course as well.
you had to know field theory before you could you do it. Because otherwise you gotta explain back the stuff them. Like you just want, you don't want to spend time explaining the maths behind it. You want to use the maths to explain the concepts. So that was the thing there. Yeah. All right, does it. So until Thursday night. Thursday night last lecture notes for exam, and then next week is we want to look at some other things.
And we're meeting this Friday as well.
Yeah. On Friday, Friday we
meeting
work
this
on labs. Yeah, Friday we work on
Good.
labs. Yeah. Ryan, you could hear me? When you go in Essequibo? Ryan.
Hey, sir. Yeah, already here.
Yeah, when you coming back?
Friday or Saturday.
Friday. Oh, I just